All right, so we're going to work on section 2.2c, solving absolute value inequality. So you might say, wait a minute, I thought we did this. Well, last time we did absolute value equations. So they said equal on them, okay? That was in section, I think it was 2.1c or something like that. I can kind of check, let's see. It was, yeah, 2.1c. I don't know if you see that. I'll just go back to it. But here's like the original lesson, right? And remember what we used to have to do is if we had an absolute value equal to b, we just rewrote it. One of the b's was positive, the other b was negative, right? And then we just solved. Okay, that's what we did. The good news is we're going to do the same thing. There's going to be one little minor change, okay? And I'll kind of show it to you guys here. Not only are you supposed to change, see the b where I highlighted the b? Not only are you supposed to change that, you're also supposed to flip this. But what does it look like when you flip an equal sign? Well, it looks like an equal sign. So you don't see me flipping it, but I did flip it. I just didn't say anything because why? I mean, you can't tell. Okay? So for today, we are going to have to flip the inequality. Okay? So I'm gonna kind of go over that with you guys in a bit. But the first thing is, how can I tell if it's an and or an or problem? Because remember, inequalities, sometimes they're ands because they crash towards each other, or they're ors, they go opposite directions. So it's easy how you can tell that. The way you're going to tell is by the way that the inequality is pointing. So if it points at the absolute value, then it's and. Okay? So if it points at the inequality, then it's an and. If it points away, and actually I'm just going to change it to just greater than, not greater than or equal to, but just as an idea. So if it points away, it's an or. So away from the absolute value, then it's or. Okay? So if it's pointing at the inequality, it's and. If it's pointing away from it, it's an or. Remember, and always has two lines that point towards each other, or they always point away from each other. Okay? So remember that. All right? And then the other thing you guys have to know, and I can kind of talk about it a little later, but is the way we're going to have to change it once we recreate the problem. So I'm just curious to see. Yeah. So let me put it right here. I think I can put it right here. How does this differ from absolute value equations? Okay, so if you're wondering, like, how is this any different? Okay, so how does this differ from absolute value equations? Well, the way it differs is just in the very end. So if you're given absolute value of x minus a, let's just say it was less than or equal to b. Then you're going to get x minus a less than or equal to b, and x minus a greater than or equal to negative b. So I'm going to highlight everything towards the end here. Notice, not just the number changes to a minus, but the symbol changes direction. But you don't lose the or equal to, okay, or you don't add it. If it's a less than, it becomes a greater than. If it's a greater than, it becomes a less than. Okay, if it's greater than or equal to, it becomes less than or equal to. Or right here, less than or equal to becomes a greater than or equal to on the second one. Okay, so you're flipping the symbol and changing the sign at the same time. Okay, you're flipping the symbol and you're changing the sign. That's the only difference. Everything else is done exactly the same way that you did the homework in section 2.1. Okay, but there is no other difference. Just that. So I'm gonna do a recall problem just to remind you of what it looked like in 2.1, and then we're gonna do examples for 2.2c. All right. So here we go. What you were supposed to do when you were doing these problems is you're supposed to isolate the absolute value. What that means is there shouldn't be like 2 times the absolute value of something, or the absolute value of something divided by 8, right? There's not supposed to be anything next to it. No absolute value and then plus 3, right? Nothing. It has to be clean by itself. Right now it's all by itself, the absolute value of x minus 2. Once you got it to that point, then you're going to break it apart into 2 problems. The first one's going to look very normal, right? X minus 2 equals to 10, like if I just erase the absolute values. But after that, I also had to do it again, but with a negative symbol on the answer. Notice, I flipped the equal sign, but you can't tell, right? You're supposed to flip the symbol, but you can't tell because equals looks the same if it's this way or this way, right? It doesn't matter. But the number you can obviously tell became a negative 10. Now I just have to solve both. So if I add 2, I get x equal to 8. If I add 2 on the other one, I get x equals to negative 8. Oh, I'm sorry, 12. Thank you. Good catch. Extra credit. Hold on. Give me a second. I got to write down, or else I'm going to forget. Thank you. Sorry. Doesn't the... Are you asking me about the 8? So negative 2 plus negative 10 plus 2. So think of it like this. You owe me $10 and you give me 2. How much do you owe me? You owe me 8, right? So I always think of negatives as money. It's sometimes easier because people deal with money all the time. So yeah, this would be a negative 8. If I would have gotten both wrong, man, that's a really bad morning. But there you go. First mistake of the year. So I'm done. That's it. Okay, that's it. These are my 2 answers. If they ever ask you to graph these, the graphs look kind of ridiculous. It's a number line with 2 points. That's it. There's no lines, nothing. It's just a point here and a point there. Like, what do you want, right? But that's all there is to doing these problems. The difference today is we're going to kind of do the same thing, but then we have to draw lines. All right? So here we go. So we're going to solve and graph. Now, is this an and or an or problem? It's pointing away. It's or, right? So I'm going to put right here, or. I'll highlight it for us. Okay? This is an or problem. That way I know that my graph better be going in different directions. Okay? Well, the occasional times they can both go the same way, but hopefully this one isn't one of them. So here we go. Is the absolute value isolated? Is there something multiplying it on the outside or dividing it on the bottom? No, right? So it's isolated. It's good. So I'm going to break it apart immediately. Y plus 10 is greater than or equal to 5. So remember, the first one looks normal. And then I'm going to write or y plus 10 is less than or equal to negative 5. Okay? If you guys don't mind, I'm going to highlight that, okay? I want you guys to kind of notice that's what changed. Okay, that's the only thing that changed. Then we're just going to do the work the way we normally would. So let's subtract 10. So 5 minus 10 is negative 5. So y greater than or equal to negative 5. And then we're going to subtract 10 on this other side. So that y less than or equal to negative 15. Are we good so far? Pretty easy, right? Same like the other one, just I got some symbols that are a little different, but it's okay. But now is the part where I have to graph it. But let's graph it the lazy way. They're going to give you graphs here. I'm just going to be lazy here because I want to be. It's okay. So I'm just going to put 2 answers, negative 5 and negative 15. So negative 15 has to be to the left. Negative 5 has to be to the right of it. Okay, remember, when you do this the lazy way, there's a couple important things. Make sure the numbers are in the right place, right? And then make sure that your lines are drawn correctly. So y greater than or equal to negative 5. So greater than or equal to is a solid dot at negative 5. And then which direction do I go for the first one? To the right. Okay. The second one, it says y less than or equal to negative 15. So another solid dot. Which direction? Left. Okay. I'm going to follow the arrows because my variables are on the left side. So then whichever way they point, that's the way I go. And I'm done. That's it. Okay. And that looks like an OR. So here we go. This is finished. Okay. Are we good? They're all like that, but of course they always like to throw in a couple like plus here or division here, etc. So, but they're all basically the same thing. So notice, here's the next one. Is this an and or an or? It's an and, right? It's pointing at the inequality. So this is an and. I'm going to put that right here. And problem. Okay. Just a little note for myself so I don't mess up. Okay. The absolute value, is it isolated? Sometimes people will be like, is it? It is. Okay, I know you might say, wait a minute, there's a 4 multiplying it. Yeah, but on the inside. I'm talking about, is it being multiplied from the outside? 5 times the absolute value, right? It's not. It is isolated. So I'm going to go ahead and rewrite this. For r less than 12 and for r greater than negative 12. Again, I'll highlight that little piece just so that, the notes for whoever's at home watching or something, they can see like, oh, there's the difference, right? That's the change. That's the change. And then we're just going to divide, right? So if I divide both sides by 4 on the first one, I get r is less than 3. And I'm going to do the same thing here, divide by 4, and I get r is greater than negative 3. Again, I'm going to do this the lazy way because I don't feel like taking forever. I'm drawing a decent size number line just so that the graph doesn't look so crunched up. Okay, first one. It says r is less than 3. So this is an open circle, right? Because it's just less than. R is less than 3. So I got to go left. The next one says r is greater than negative 3. So open circle at negative 3. And it's pointing to the right. So I'm going to go to the right. What do they have in common? Now, guys, I do have to warn you guys about this. I didn't mark you wrong if you did this and left it like that. Some of you guys graphed it for me and you left it like that. Don't do that because that's not the answer, but I got what you were saying, so I gave it to you. Okay, I didn't mark you wrong because I knew where your mind is. Okay? But make sure that you draw the final answer, okay, after you do that. Okay? And remember, if you want to erase the other work, that's fine if you just want that one little line. And if you don't even want to do all that, that's fine too. Just make sure you're getting it right. Okay? But yeah, if you're doing it where you're coloring it in, that's fine. I get it. You're telling me, here's my answer, but you have to draw a line. Okay? You have to draw an actual final line. So there we go. This is our solution for this one. And before I move on, any questions so far? So can you say that it's basically the same as like 3 sections ago? Just with the graphing now, it's a little different, and we do have to flip that inequality, but other than that, it's the same idea. All right, we're going to do 2 more, okay? I'm trying to get to some that look a little different. All right. Now, I do want to tell you guys, and I apologize for this, because normally I don't do this, but I'm not actually doing any homework problems today. There's only 8 problems, but they're all kind of like this, and there's only one that's kind of difficult looking. And I'll kind of work on one that just looks like it. But I think this homework's pretty easy, so I didn't want to take it all away. So I do apologize. I'm doing 0% of your homework this time. But these will be helpful. Is this absolute value isolated? No. What's bothering it? The bottom, right? Yeah, the divided by 5. So to get rid of division by 5, I need to multiply, right? So let's multiply by 5. Now I'm going to get this 5, I'm going to throw over there by multiplication, okay? That's the way I usually do it. I just put a little arrow and I put times on it so I know that I'm multiplying. So this becomes the absolute value of 2m is greater than 30. Okay? Now, it is isolated at this point. Is this an and or an or problem? Say again? Or. It's pointing away. If you ever forget, a little trick that I was told was they said, okay, remember how when you graph an and problem, they're going towards each other? They're like, it's pointing towards the absolute value, so they go towards each other. And when they're going away from each other, it should be pointing away from the absolute value, right? So away goes away, towards goes toward, right? So if you're going towards the absolute value, that's an and because they're going towards each other, okay? If you're pointing away from the absolute values because the lines go away from each other, right? For me, word association was key because remember I told you I'm a visual learner, so I need cues, I need hints, ways to memorize things, right? So anytime a teacher told me something, I'm like, okay, away is away, and towards is towards. So like that always helped me. So anyway, here we go. 2m is greater than 30, or 2m is less than negative 30. Remember, you change the symbol, you change the sign. Okay, you gotta change both. So I just divide both sides by 2. M is greater than 15. Divide this by 2. M is less than negative 15. Let me fix that here. So let's do a lazy graph here. Negative 15, positive 15. So the first one says M is greater than 15. So greater means open circle at 15. Got to go to the right. Okay. The next one says M is less than negative 15. So open circle, got to go left. So open circle goes left. And there you go. Again, hopefully you guys are like, yes, same as before, no big deal. Okay, so hopefully you guys are okay with these. We got one more to do. And this is the one that looks like the most complicated from your homework. So this is an exact replica of your homework, only I changed the numbers. Okay? But it's going to look pretty much like this. Like it might be like a 3 plus 7 something, less than or equal to, I think like 15 or 14, something like that. But same idea. This will be our last one. All right, so let's go ahead and start solving. Obviously, you can tell that the absolute value is being bothered by a 5 that's adding to it and a 9 that's multiplying it. A common mistake that I saw on the quiz, is that people were adding these together. Okay, don't do that, because 9 is multiplying the absolute value. So you're supposed to do the multiplication first if you were going to do order of operations, but we're not. And remember, you don't distribute into the absolute value. That's a no-no. You cannot do that. You can distribute into parentheses, not into absolute value. Okay? So, what do I want to move first? The 5. Let's get rid of that 5. I'm going to subtract it. Okay? I'm going to subtract it. So this is going to leave me with 9, absolute value of 8 plus x, less than or equal to 14. Now we're going to get some weird fractions, so I hope you guys don't mind. That's okay. Because I made this problem up. Sometimes when you make stuff up, the answers don't come out as nice. Okay? So, my next step is to get rid of that 9 next to it, right? So I'm going to divide by it. Okay? Let's divide by 9. So I get absolute value of 8 plus x is less than or equal to 14 ninths. Okay, 14 ninths. All right, again, don't be scared with it. Just use a calculator, it's fine. So at this point, it is isolated. I look at my inequality. Is this an and or an or? It is an and, right? So I'm going to put right here, and. That way I know. Now, by the way, sometimes I get students to tell me, why don't you put and in the very beginning? And the reason why I don't is because what if that 9 was a negative? A negative 9. Yeah, I'd have to flip it, right? And instead of an and, I would have had an or problem. So I have to wait until it's isolated before I make the call if it's an and or an or. I can't do it immediately because there could be some movements that occur that change the inequality. Okay? So don't automatically say and. It did turn out to be and, but it doesn't always do that. Okay? So, all right. So here we go. One of the questions is going to be 8 plus x is less than or equal to 14 ninths, and the other one's going to be 8 plus x is greater than or equal to negative 14 ninths. Anybody have a calculator? If you do me a favor, bring it out. I'm pretty sure I could do it in my head, but if I can save myself a little bit of extra effort, I'd appreciate it. But, all right, let's subtract 8. Okay, so that's x less than or equal to, now 14 ninths is 1 and 5 ninths. So if I subtract 8 from it, I should get negative 6 and 4 ninths. Is that right? Yeah? All right. Which is negative 6 and 4 ninths would be 6, 4 ninths, negative 54, negative 58 over 9. Is that right? Someone have a calculator? Someone's checking me right now, so I'm going to wait right now. I'm going to pause the video just so we wait. All right, now let's do that again. I'm going to subtract 8 there. So that's x greater than or equal to, that's negative 9 and 4 ninths. No, and 5 ninths. So that's 81, 86. So negative 86 over 9. Okay, so those are my answers. Now, if I'm going to graph this, I probably want to write them as improper fractions. Okay, and we kind of already did that when I said it earlier. So negative 58 ninths was negative 6 and 4 ninths, and the other one was negative 9 and 5 ninths. So the negative 86 over 9 goes here, and the negative 58 over 9 goes there. Okay? Because the negative 58 is negative 6-ish. And the negative 86 over 9, that's negative 9-ish. So that's smaller. Okay? All right, so let's draw. So for the first one, negative 58 over 9, it's going to go left. It's going to be a solid circle going to the left. And then the other one is going to be a solid circle going to the right. Okay, so if I just highlight what they have in common, which is right here, that means that my answer is from here to there. And this is basically going to be your homework. Hopefully, whoops, let's see if this actually does a box. I don't know if it will. Yeah, it did. But hopefully you don't get any weird fractions like that. But if you do, you got calculators to use. You can use them. But that's going to be your lesson.